All right, thank you everybody for coming out to the last ISSessions session of the term. This is also the last session with the current exec team. Afterwards, the new exec team will be taking the reins. We got a few of them presenting this week, and I'm sure you'll get introduced to the rest of them in due time. I hope you guys all give them the same attention and excitement that you gave us this year. It's been real fun being an exec this year. But enough about the future, let's focus on tonight's session. So we're starting off with the news roundup as usual. Afterwards, our middle segment, we're going to be looking into various projects and things you can pursue over the summer once we're done with school. Then, after a short break, we'll be joined by Samy, who's going to be talking about how to read code for security practitioners. So without further ado, Jackson Y, who's online, you can go ahead and unmute and present your story. I can't. Mason, you here? You can? Is he? I don't hear him. Wait, let me check my settings. Just one sec, Jackson. We can't hear you here on campus. Try again.
Hello, hello.
Okay, perfect.
Should I start from the beginning?
Yep.
Okay. So in today's article, I will be discussing new method hackers are using to self-extract archives to spread malware. They are also called SFX for short. Self-extracting archives are executable files that automatically decompress and extract their contents once opened. They have been long used for legitimate purposes, such as simplifying software installation. SFX archive files can also contain hidden malicious functionalities that may not be immediately visible to the file's recipient, states CrowdStrike researcher Jai Minton. In the case investigated by a security firm, compromised credentials to a system were used to run a legitimate Windows accessibility application called Utility Manager, also known as utilman.exe, and subsequently launch a password-protected SFX file. These files are specifically engineered to run PowerShell, command prompt, and task manager with NT authority/system privileges by providing the right password to the archive. This type of attack is likely to remain undetected by traditional antivirus software that is looking for malware inside of an archive, stated by Jai. To mitigate these threats possessed by the attackers, it is recommended that SFX archives are analyzed through unarchived software to identify any potential scripts or binaries that are set to extract and run upon execution. Now I'll pass it to Patrick for the next segment.
My article is how FBI cracks down on the Genesis market, 119 arrests in the cybercrime crackdown. So law enforcement dismantled Genesis market and illegal marketplace. The crackdown named Operation Cookie Monster involved authorities from 17 countries, resulting in 119 arrests and 208 property searches in 13 nations. The Genesis market offered access to data stolen from 1.5 million compromised computers worldwide, with more than 80 million credentials. Prominent malware families used including Result, Raccoon, Redline, and Danabot. The market was accessible over the ClearNet, making it easier for lesser skilled threat actors to obtain digital identities, to breach accounts and enterprise systems. FBI gained access to the Genesis market back in December twice, in December 2020 and May 2022, obtaining information pertaining to about 59,000 users. The packages of stolen information were sold from anywhere between 70 cents to several hundreds of dollars. The Genesis market advertised credentials connected to financial sector, critical infrastructure, and government agencies. The emergence of a new dark web marketplace called Cynic shows that the market for legal services continues to be a fruitful business. Cynic is probably geared toward financial fraud, money laundering, and identity theft, and offers utilities designed to get around anti-fraud solutions, takedowns. The Genesis market is expected to have a ripple effect throughout the underground economy as threaters search for alternatives to fill the void left by the marketplace. Next up is Tom.
Hey everyone. So the news story that I'm bringing for you guys today is about Western Digital. So Western Digital, one of the world leaders in digital storage solutions, suffered from a cybersecurity incident this week. They made multiple statements on the incident that caused and may continue to cause disruptions to parts of their business operation. And without explicitly saying so, the company said that the attack was a ransomware attack, which ironically the company promotes easy, efficient, secure cyber protection with an award-winning backup with an AI-based defense against ransomware. Western Digital is a massive target for threat actors, with Western Digital reporting $18.7 billion in revenue for 2022, and it is estimated that over 40% of their revenue comes from cloud services. Western Digital made no comment on the status of their cloud backups, but it is important in the event of a ransomware attack to have backups, which should not be connected to a live network at all times to avoid the backups being affected as well. It is likely the cybersecurity incident not only affected Western Digital's infrastructure and data, but also their status as a secure cloud services provider. And, oops. My last one. Oh, all right. That's it.
No, Ab's up next. Oh, will this be?
Oh, gotcha.
Thank you. All right. Hey guys, my name is Ab. I'm one of the new content developers. All right, awesome. So the story I'm presenting today is a new ransomware group, Money Message. They first appeared on the 28th of March. So this has 5 victims, but as of today, they're at 6, MSI being the latest one this morning. The malware is written in C++. It comes with a JSON file that you can specify the encryption cipher to use, and you can also specify which files to encrypt. It's according to the source Bleeping Computer, it's really slow compared to other softwares. It's also very sloppy. By default, once it's run, of course, it doesn't encrypt any system files. The first thing it does once launched, it deletes any shadow volumes. It then closes any kind of irrelevant service, so anything like Microsoft Office, SQL. And unlike regular ransomware, it doesn't add extensions to the end of the files unless you specify it to do so through the configuration file. Once the encryption is done, just like any other ransomware, it creates a ransom note with a Tor link for negotiation. It's active still as of today with no known decryptors and an unknown initial infection vector, but it's most probably going to be through phishing. And yeah, that's it for me. Thank you.
Hello everybody, I'm Jamal. I'm the new content coordinator. I would love to take you guys time just to talk about Microsoft Security Copilot. It was a new technology that Microsoft announced this week and I thought it was pretty cool. So essentially what Microsoft Security Copilot is it's an AI that uses ChatGPT 4 and Azure. Essentially what it does is it can read threats or attacks that are going on at a company live. And it can basically produce lists and data for security researchers in order to understand what is actually happening in real time. So something that is kind of sucks is that normally you have to, once a threat happens, you have to actually go through, sit down, figure out what's going on, understand the attack, and then work to fix the issues. What Security Copilot, it already does that for you, compiles the things that are going on live for you so that you can work to remediate the issues right away. And in some cases, from what I read, it actually will give you the steps in order to actually stop the attack from happening, which is pretty cool. So for example, you can ask Security Copilot to give you a brief overview of a recent ransomware attack, a comprehensive view of an ongoing attack's scope and severity, a list of steps to follow and remediate an incident, or feedback on how to improve its performance or accuracy. So something that I thought was really cool that they did. You can actually take, in this case, what this image is showing, they took a PowerShell malware and they put it into Security Copilot, and it reverse engineered the malware essentially and showed how it was built for the security researcher to basically say like, oh, okay, this is actually what happened with this malware. How did it get into our system? This is how it was built. And you can take steps to actually go ahead and prevent that from happening again. So that was my piece. Thank you, everybody.
All right, thank you, content team, present and future, for delivering the news for us. So for the middle segment, like I said, we're going to be getting into various projects and things you can pursue to take up any sort of free time you might have after school. So I'm just going to switch over to that slideshow, and then we'll get started there.
Okay. Hey everyone. So yeah, we did this last year, if you guys remember. So the summer is a long time, and if you're not doing anything, you can kind of get rusty. So hopefully tonight we can talk about some things that you can try, you can do, you can attend, and maybe give you some ideas of stuff to do. Yeah. So just a little rundown on what we're going to talk about today. So first, a little bit of rest and relaxation, because that's very important. We're going to go over some learning websites, some CTFs, certifications, personal projects, and events and conferences. Just so, yeah. So first, I'm just going to talk about rest and relaxation. It's important. I know you have like 5 months of summer, but if you spend your whole time working, you're going to get burnt out. And believe me, if you talk to like anyone in the industry, they say burnout is high. People quit their jobs, people like mess up their careers because they get burnt out. It's good to kind of start early on those like mental health habits so you don't burn out, because no one wants to burn out, right? So you have to have that good balance. So even if you are going to be doing some of these things that we talk about, make sure you do some like enjoyable things, relax, go for a walk, go outside, hang out with friends, stuff like that. Have hobbies. And yeah, so the things we're going to talk about today, they're good for your learning. They're good to do. I'm not going to say don't do them, but don't do them at the expense of your mental health. Take some time off after exams to like let that burnout stop a little. And next, we're going to be talking about learning websites. I believe that's an arrow.
Hey everyone. So to start off this segment, I'm going to outline some helpful websites you can check out over the summer to do some extra learning. So first I have here is Linux Journey. This is a good site if you're just starting out on Linux and want to familiarize yourself with the system. It gives you a pretty good introduction into different parts of Linux, ranging from the command line to text manipulation with Vim and Emacs, and configuring the Linux terminal or network sharing. So each module looks like this, where you'll see the topic on the left-hand side, an explanation here, and an area to test your knowledge. The next thing I have is Try Hack Me. You've probably already heard of this one. It's a pretty popular site for hands-on cybersecurity exercises and labs. If you navigate to learn, you'll find structured learning paths and modules depending on the topic that you want to learn about. Completing labs gets you points, and you can also compete with other users. You can also use Try Hack Me for free, but some features and labs are only available with a subscription. Next is Over the Wire Bandit. This is a war game for beginners, so you start at level 0, and solving each level gives you information on how to solve the next. You connect to the game through SSH, and the purpose is to improve your skills on the Linux command line and other hacking skills. And lastly, I have O'Reilly, so you can access this using your Sheridan account. And here you have access to the entire O'Reilly library, and it has a ton of technical textbooks and video content that you could access for free. You can also find the textbooks for your courses on here, or at least some of them. On O'Reilly, if you scroll to Learn by Role, you can select a role like Cybersecurity Engineer, which you want to focus in, and then select specific skills within that role that you want to improve. O'Reilly will then suggest you popular courses, video tutorials, or textbooks that will help you improve your skills in that role. So they have a lot of textbooks, including all the No Starch Press textbooks, which are a really good technical resource. You can also view some textbooks before they're even published. You can also find textbooks for certifications. They have a lot of practice tests and also complete study guides. I'll pass it on to CTFs.
Okay, I'm back. This time to talk about CTFs. So as you might have attended our amazing CTF put on by our great CTF team this year, you might have gotten a little taste for them. Maybe you want to do some more. And so they're a great way to learn more, improve your skills. Every CTF I've been to, I've learned something new. You can try out different challenges. Yeah. And so ctftime.org is a great website. It shows basically a huge list of upcoming CTFs. And you can even just make a team on that website and sign up for a CTF. And it'll show all of them. Some of them are in person. They're all around the world. Like I saw some in like Switzerland or like Sweden, but obviously those are a little far. But most of them are online. Pico CTF is another great resource. It's open year round and has basically just a bunch of challenges that you might find on a CTF. I'm gonna go in a bit, but basically every year they release a bunch of challenges, and you can see any challenges from the past years and do any of them you want. And I was just gonna say, you could even send a message to your friends or anyone in the ISSessions server to try and make a team for one of these events, because they are more fun in groups. There's only so long you can just stare at something on your own. You gotta have fun with it. And yeah, so just this is CTF time, lists, I don't know why I said CTF twice, but lists upcoming CTF events. Most are Jeopardy format, like our own CTF. But so there are a few that are like attack and defense, where basically some teams are on the attack and some teams are on the defense. And then it's like actual systems where you're trying to hack in and actually defend. So that could be kind of interesting. I found around 40 that are listed for what would be our like school summer. So literally any weekend you want to try a CTF, there's probably a CTF. And yeah, most of them are online. And then Pico CTF, like I talked about a bit, they have a bunch of different categories. There's about 300 challenges in total on the website right now, which is a lot. They have web exploits, crypto, reverse engineering, forensics, and general binary exploitation, and there's a few that aren't categorized. And like I said, they release some every year or for some like specific events, and you can see any of them. So you can just go on and basically try any challenge you want. It's a great practice for CTFs, or if you just want to like learn more. And then here's just a few upcoming CTFs I found on the list. There's Crew CTF, which is in April, UMD CTF, which is also in April, Just CTF in June. There's a Google CTF in June, which like that's a pretty big name. You might want to try that out. And then there's the DEF CON CTF qualifier, which is online, but if you do well enough, you get to go to the finals, which are in Vegas. I think Sing is going to talk about the conference more, but that's like a huge cybersecurity conference. I'm sure it's pretty competitive. And yeah, on to certifications. That's just
Okay, hello everyone. I'll be talking about certifications for today. So just a little bit of briefing here is that certifications aren't necessary for when you're applying to jobs or internships, but they can give you an edge in the market, meaning that it'll make you more marketable to your next person. Having any certification is better than none, and there's a lot of certifications depending on what sort of skill set you want to have. And if you're going into co-op or an internship, usually they don't require any certifications. So here are some recognized institutions that actually sell you certifications. So there's ISSesquared. That one's a really big one. I'll talk about that more in a bit. There's ISACA with their 4 main certifications over here, CSM, CISA, C-RISC, and CGEIT. There's CompTIA, if you're familiar with like Security Plus, Network Plus, A Plus, Penetration Tester Plus, and there's like a lot more. There's Ethernet Security, which has the EJPT, which is the Junior Penetration Tester certification. There's the GIAC certifications, the one in yellow over there. That one, they have very expensive certifications, like thousands of dollars. Usually those are really popular for people in defense. And TCM Security, which has the PMPT, which is a penetration testing certification. So here are some examples of jobs where certs may help. So if you're gonna think about doing any certifications, it's best just to look at the job market first to see what's required, see what's popular. Again, like I said, it's not required for every single job, as you'll see here. So at the very top left, you can see Tundra, security consultant, data encryption and tokenization. Security certifications include CISSP, CISA, CSM, C-RISC, Certified Ethical Hacker, and then GIAC. It's usually one of these, but you could tell already that this sort of position will require years of experience because of the CISSP. So CISSP comes from ISSesquared. That's like a management certification that requires 4 to 5 years of experience. You're going to be saying that specific certification a lot. If you also go on LinkedIn and look at like other people who worked in cybersecurity for a very long time, it's possible, or it's more than likely that they'll have that certification in particular. And it's also listed as an asset, meaning that it's not required, but again, it'll give you an edge. So another one here would be like SOC operator, Security Operations Center for Interact, which is for like payments. Here, education and security clearance. So graduation with a degree from post-secondary or minimum of 1 year of practical experience within the past 5 years. And then it lists the certifications over here, which is the NS GIAC GSOC, which is the GIAC certification for security operations centers, including the Network Plus, Security Plus, which are from CompTIA, or other cybersecurity certifications. So again, any one of those to give you like an edge, but here it seems to be required. Level 2 clearance, and eligible to work in Canada. And then here's one from Ernst & Young, which is a consulting firm, one of the big 4, I think. This one's on site in Toronto. This one's for security analyst, threat detection and response. Available all around the clock, basically. Experience with Defender, Sentinel, and Python scripting, and Custo query language. This one doesn't have any requirements for a certification. It'll probably help to have one, but again, I just want to illustrate the point that it's not necessary to have one, but it could help. So if you have time over the summer, I would probably like look into any sort of certifications depending on what sort of area of cybersecurity you want to work in. Could be very general and just in IT. Could be anywhere in penetration testing, so you could get like an EJPT, PMPT, or SCP, which is like hundreds of dollars. Or you could wait and get hired full-time by any company when you graduate. And if you do get hired, they could probably invest in you and they could pay for your education for certifications. So the point is that you have many options open. Certs can help, and make sure you look at job postings to get a sense of what the market needs. Okay? And then summer projects.
I'm Tio. I'm going to talk to you about summer projects and mostly about how you can make sure you follow through with them and how to pick proper projects. So when it comes to what a project should be, I think it should be something that's interesting to you, not really anything you just find online and you're like, oh, what's a good cybersecurity project for beginners? Mostly just because you're going to burn yourself out looking at projects that other people find interesting and you're never really going to get any work done. It's going to feel just like another class. If you research similar ideas or topics to the project that you find interesting, like let's say I have a problem at home and I want to set up a server for my house, but I don't want just anybody to have access to it, how can I make it secure? You'll be able to find like more interesting ways of doing it and how other people have done it and how to make it more interesting for yourself. When it comes to actually working on your project, it's important that you start with a goal. So set something out in the distance, just something that you want to achieve, whether it's I want to get better at programming, or I want to get better at encryption, or I just want to solve an issue that I have. You should plan it out. You should set a time scale, set like a due date almost for yourself. Like by the end of summer, I'd like to have this done. And then you just have to work on it consistently. So when it comes to actually completing it, again, consistency is key. You want to create accountability for yourself. So maybe if you tell a couple people about the project, it'll give you a bit more drive to actually get it done. So that way they don't know that you started something but didn't finish it. And if you set yourself a schedule, like maybe I'm going to work on it from 9 to 10 every day, at least then you know that chunk of time is allotted to your project and you know something's going to get done every day. Again, it doesn't matter if you get a lot of work done every day, as long as something gets done on your project, you'll feel like you're making strides towards completing it. And then I have a couple example projects here. So let's say you want to create like a network traffic analyzer, if you want to get more into the networking side. Again, if you want to work on encryption, try to encrypt like a text message or an image that you have. Creating like a home lab, so basically setting up a server and setting up Active Directory on it, or like an email server, setting up firewalls, basically just any of the administrative tasks you'd have to set up. Yeah, I think it's important that when you do a project, you think about it kind of almost as if you're at work, but a little more relaxed, as if your company gave you something to accomplish, and how would you go about accomplishing it as efficiently as possible and making sure it gets done. But again, it is the summer and it's important to set time aside for yourself. So yeah, that's my 2 cents on projects.
Hi everybody. So I'll be talking about conferences and events that are available throughout the summer term. Excuse me. So I'll preface by saying that most of the larger conferences are targeted towards industry professionals. And so once you actually get into the career, into the field, the company that you work for is more than likely willing to pay, as Jess said, to invest in your education, your future career. That being said, though, there are accessible options for students. Sometimes there's a student discount, sometimes it's free. And that being said, the first conference I found relevant to us is Texpo in Toronto. That's going to be hosted in May. It's at the Marriott in downtown. The prices range from $17 to almost $700. $700 is for if you want to take the full package, full access to all of the events, speeches and whatnot, including training. So it's more so introducing next generation technologies, talking about technologies introduced into internet, mobile, ad and marketing tech, software as a service technologies. And it's more so for the experience of the new technology than anything cybersecurity related, but it's a good introduction to what's new and emerging. And it did note on the website that there's a limited number of free passes, so if you attend it quickly, you can probably get in for free. The next big event is at the end of May, hosted by CyberX. It's Canadian Women in Cybersecurity. I know the majority of the industry isn't women, but if you are interested in attending the event, it's an all-day event at the Sheraton in Richmond Hill. And again, the package ranges from free to $259. It includes visits to, again, more talks. And basically, you can use that as an event to network. They want to highlight achievements in innovations of diversity in cybersecurity, so not just focus on specific demographics. And it's essentially, again, another networking opportunity where you can have conversations with people who are in the industry. Recon is one of the more expensive events, but there are a lot of training sessions that have really good value. Right now, the ticket price is between $500 and $700 for a student. So if you're willing to spend it and you're willing to invest in that, then that might be a choice for you. It's in Montreal in June. Like for industry professionals, they can get upwards to like $5,000. So you can see the value relative to you being a student at this point. So like I said, if you're willing to spend it, then this is a great opportunity. And finally, for most of us, we probably don't want to spend hundreds of dollars on learning the professional industry stuff yet. So there are free options like with Toronto Area's Security Clash, aka TASK. They have a monthly meeting at the end of the month on Wednesdays. If you're interested, you can sign up on their website at task.to. And if you're willing to wait, some of the more known events are going to happen in October during Cybersecurity Awareness Month in Canada. So that's events like CEDA, Sector, Data Connectors, Cybersecurity Conference, all in Toronto, all accessible to us. And as Jackson mentioned, DEF CON 31 is in Las Vegas in August. I actually don't have too much information regarding the event itself, but you can visit the website. There's tons of information there. Just look it up. It's one of the bigger cybersecurity events, especially in North America. And there's tons of vendors there, tons of training, Q&A, and you can get some networking opportunities there too. During May, if you are willing to do some traveling as well, the Vancouver area actually has a whole bunch of different security conferences as well. You can visit this link here, infosecconferences.com, and there's just a whole bunch of more available during May there. And then finally, the alternative is to just search cybersecurity on eventbrite.ca. There's a lot of constantly hosted conferences sort of niche to certain cybersecurity topics. If you just go to eventbrite.ca and search cybersecurity, you'll find a bunch of like 1 hour conferences, 30-minute conferences, 2-hour conferences, and you'll learn a lot there too.
All right, thank you, content team, for the middle segment there. I hope you guys got some inspiration and some ideas about things you might want to try out over the summer. So with that, we're going to be taking our break. Mason will be posting the CCR code for you. He'll also be posting a YouTube video to a previous ISSessions recording. So since this is the last session of the term, I'll be beginning to send out emails to you guys regarding your CCR hours. So as a reminder, if you have 20 hours accumulated, you'll be able to add ISSessions member to your CCR record. If you don't have 20 hours, don't worry, because we're still hosting sessions on a monthly basis over the summer. So you still have some more opportunities to hit that 20-hour threshold. If you have any questions, don't be afraid to reach out to me. We got our CCR code up on screen, and we'll be taking, I guess, 5 minutes. So 7:42, we'll get started with Sammy's talk. All right, I hope you guys enjoyed your break, but we're ready to get started here with Sammy's talk. So Samy, if you can just share your screen, and I'll switch over to that. All right, video is all good on our end. Can you just test the mic real quick?
Yeah, sure. Can you hear me?
1 sec, I'm just gonna try cranking up the volume on our end. That's a loud door. Try again.
Can you hear me now? How's the volume? Too loud?
Just gonna crank it a bit more. Let's see. Try again.
Why again? How's it now?
Perfect. All right. Whenever you're ready, you can get started.
Yes. Okay, let's do it. So, let's get started. So I'm here to talk about something that's not exactly technical. It's more like a meta skill. It's a skill that you use to learn to use your other skills efficiently and effectively. And that's how to read code. And some of you might think like, what do you mean by reading code? I'm going to clarify that. But if you think about it, as blue teamers, as defenders, what are we defending? We're defending data that's being processed using code, right? We live with the code. We're making our money with the code, right? We're using tools that are written in code, in whatever language that you're being used. As red teamers, what are we breaking? Breaking other people's software, right? We're getting around it. We're breaking the code, right? At the very base, it is the code base that we're working with. But I don't know if you noticed or not, but every resource, every book, every course, every boot camp, everything teaches us how to write code, but nobody teaches us how to read code. And we're going to solve that today. Okay, my name is Samy. I'm a staff product security engineer at Okta. The whole title looks like a passport. It's long and has special characters in it. That is me, but when I was younger, I had a lot more hair and I didn't read this much, so don't question it. Okay, what are we going to cover today? We're going to talk about some soft skills and kind of like the mindset that people get wrong when they're reading the code. Most of these I'm pretty sure you're gonna relate to, and I'm also gonna show you some tools to make your job easier. So before that, let's get one thing straight. Why do we need to read code? Well, I talked a little about it, but these are the actual use cases. Sometimes you read a piece of code and you want to extend it, you want to add a feature to it, you want something, you want to add to it, right? Or very good idea, super great for the resume, amazing idea. You should give back to the community, to the open source community, right? Imagine like think about all the open source things that we are using for free with the code available. If you have the opportunity, that's a good thing. Also, as I've been on both sides of the table, I've been the interviewer and the interviewee, right? Every time I see someone have like a list, a section of their open source contribution, my eyes just light up. I've had people who contributed to big names like Google or Mozilla Firefox, right? And that means something. That means that these people care and do have the knowledge. So that's a very good way to build resume. Sometimes you want to fix a bug. You find something, you want to fix it. That also can count as a contribution, right? You find something, you want to fix it. Sometimes you actually want to find a bug because you are doing vulnerability research. Like imagine you are researching a what's the recent one that WordPress WordPress plugin, right? You're researching for vulnerabilities, so you need to be able to read the code effectively. And sometimes you just want to understand it. You want to learn it, like you're learning Rust, and you want to know how is it being used with, like say, Linux kernel. You're learning Ruby, and you want to see how, like for example, Metasploit is handling multiple threads for different listeners, right? You want to look at the code, see how they're doing it, learn from it. Sometimes you want to do a code review, and a last one, it's a little bit controversial with thread modeling, because I'm saying controversial because some people say when you're doing thread modeling, you shouldn't be looking at the code. Personally, I do, because I'm on the I'm of the school of thought that says code is the truth. No matter what your documentation says, code doesn't lie. Your documentation could be outdated, right? So that also helps there. So these are some of the, I think, most of the use cases. Okay, so another question about what do I mean by reading and reading code versus writing code, right? So reading code is much harder than writing code. So all of you who have written code before, who have written some kind of software or program or script, doesn't matter what kind or how big, you know that it's easier to implement what you have in mind than to go on GitHub and read someone else's code that does the same thing. Sometimes it's so easier that you rather to rewrite the whole thing from scratch versus reading someone else's code. But one of the reasons that it's harder to read code is because there is no single solution to a problem. There are so many solutions. Like imagine like something as simple as multiplication, right? We all learned it at school. We know how to use a calculator. But when you go deep down into it, there are so many ways of doing one simple operation, right? Most of us never think about it. We just use asterisk, like 2 times asterisk x y x asterisk y, and return it, right? But there are so many methods like long, grid, lattice, Russian peasant, quarter square, Karatsuba, Shoha, Strassen, right? These are all different ways of multiplication, and they're available in different software like scientific calculators or other stuff. So that's one of the reasons. Another reason that I think no one no one teaches us how to read code, because in natural languages like in English or in any other language, reading and writing are very much tightly coupled. If you can write it, you can also read it, right? I can't think of, there might be, I don't know, you guys are hackers, right? You might find an edge case, but I can't think of a natural language where you can write it, like meaningfully write what you have in your mind, but you can't read it, right? But that could be the case in code, right? Someone writes something, but you cannot read it, or it's not easy to read. Okay. Okay, so now imagine this situation. I usually find because of my job, I work as a detection engineer, as an application security engineer. I work with a lot of code bases. This is one of the situations that I usually find myself in. You're given a code base, right? A huge one, probably millions of lines of code, and you're asked to assess it. You're asked to evaluate it. You're asked to secure it. Now what? What's the plan? What are you gonna do? Just stare at the code? And if you're in my shoes, you may like your organization may have thousands of code repos actively maintained and deployed and working and changing, right? So what's the plan? What are you gonna do, right? So maybe we're gonna go over that. Here's the first thing that most people do, and I don't know. Tell me what you think. When they approach a new code base, they think, how does it work? They see a piece of code and ask themselves, how does it work? That's the worst question you can ask yourself. That's wrong. Don't ask that question. Instead, ask this. What problem is it trying to solve? This simple this simple shift in your mindset just changes everything. This is you can't really do that. I'm going to show you with a few examples that this is not how it works, right? We think this is how it works, but it's not. What you need to understand first is to understand what is the problem that this code is trying to solve. Why does it even exist in the first place? Why am I looking at it, right? So, context is king. You need to understand context. Okay, so look at this program and tell me what it does. I'm giving you a few seconds. It's a piece of C code. You can see that it does some stuff. Pretty easy, right? And many of you probably have used it or know about it and ask yourself why such a program exists. This is one of the Linux command lines, GNU tools. They're open source, and it does this. It just prints Y. That's one letter. Y. It's a yes command, right? But after I tell you this, after I tell you what it is, right, and what it does, it basically answers the question like if you're writing a shell script and you need to answer why to your questions, you can just pipe the output of this to the other program and it just answers why. Yes, right? Now, this code makes more sense. Now, you can see that here we have the letter that's being printed. Here we have the optimizations for the buffer, right? Now it starts to make sense. Oops, sorry. me 1 second. Yeah, after you have the context, that piece of code starts to make sense. You're not going to understand why everything is being done, the way it is being done, but it starts to make sense. Okay, so I said that we need more context. But how do we get that context? That context doesn't only exist inside the source code, it's around it, right? So you have to look left and right and top and up and below. So the first way that you gain context is by becoming a user. Whatever software, whatever code base you're analyzing, you need to become a user. Just why did it come to existence? Because someone or something was going to use it to do something. So you need to become that thing. You need to become a user, right? And just get it running, right? Get that piece of code running, and just go through the simplest use case you can find. I'm going to use web applications here for most of my examples, but it applies to everything. But web applications are more easier to understand. If you're trying to analyze WordPress, right, just install it, log in, post something, that's done. You understood the very core of the context around that piece of software, right? Next, after you understood the first context and you became a user, you want to become a power user. You want to go deeper. And for that, you need to set up a working development environment, as in if you're being paid to change that code and ship it out, right? You need to create, set up a working development environment. I'm going to go through these in my demos, but just hang on. Okay, most of these projects, like whatever you can think of, most of them, the good ones at least, they come up with setup or contribution guides, right? So you can follow those guides and get a working environment. You need to use a proper setup. Don't use something like that just like kind of works, sometimes works, right? You need to use something that actually meets your needs. And there are a few things that you need to have. First thing is a search functionality. You need to be able to search through your code base. That sounds easy, right? But it's not as easy as it sounds. There are a lot of nuances in how the search is done. If you don't want to pay for like different IDEs, I'm going to use a paid one here to show you the what I mean. But if you don't want to use it, you can use grep. But I really suggest using a rip grep instead of grep. RIP grep, rip grep instead of grep. It's faster. It has better default, like it doesn't search inside the virtual environments or node modules or like some. It's good. Give it a try. So you need search. You need another functionality called go to implementation. You see a function right in like in middle of your code or a method or whatever. You want to say, well, what does it do, right? You don't want to do a lot of switching back and forth between the windows. Good IDEs, good code navigation tools have this functionality built in. Actually, VS Code, which I don't really like, but that's for another presentation. Why I don't like VS Code that much, has this functionality built in. So you can do that. So search, go to implementation, and the third one is find usage. You find something, oh, that's an interesting one. Can be vulnerable, but depending on how the user input is passed into it, right? Where is it being used? That functionality helps with that, and I'm going to show you later what I mean by that. So it finds all the places in the code that piece of like whatever you found is being used. A debugger, I always say that I have two superpowers: meditation and debuggers. Debuggers are amazing. I don't know why people don't use it. I just don't understand it. Well, I kind of understand it. They're not easy to set up. There is a small upfront investment that you need to do to get it running, right? And it's easier to just use print statements, but print statement is not a debugger. And I'm going to tell you and show you why it's not a debugger and how a debugger is a better solution. Bookmarks. It's optional but highly recommended. If you can bookmark uh, different parts of the code, you can easily navigate between. It's optional, but it's recommended, and we're going to see that. Okay, so we got the tooling. out of the way. Now let's talk about another, the next thing that you can use, you should use to gain more context. That you're gonna hear that word over and over again from me. Context, right? Another tool that you can use to gain more context. Another thing that you can use is not a tool, is the data model. So that application doesn't exist just because it does, right? It takes in some data, does some processing on it, whatever it is, it's a black box to us, at least right now, and output some data. So what does the input and output look like, right? It's a key to deeper understanding. One of the places you can actually find that is the DB schema. Is it like SQL, no SQL, doesn't matter. There is a place that this data is being stored. Go and look at the data with your eyes, right? What are the fields? What are the values? How does it look like? For example, look at this. Can you tell me, this is a table, columns in a table, right? But I'm not telling you what it is. But just by looking at the column names and the column types, can you tell me like what's the actual use case? Like what is it being used for? I wish I could hear you, but I assume that you all said registration or login, and that's correct. Username, password, nice name, email, registered, not registered, status, active, inactive, activation key, display name. That's the WP users table from WordPress. But just by looking down, it didn't tell you anything, right? It makes sense. It gives you some more context. Another place that you can gain what? Context. This is good. You're all gonna dream of context this tonight. Another place that you can get these more context is the API docs, like in Swagger, OpenAPI, OpenAPI specs. Sometimes I'm not a fan, but Confluence in your organization, GitHub README files, or like wikis or whatever, right? Check out this one, for example. Can you tell me what this one does? Or can you guess? I mean, I'm not expecting you to give me the 100% correct answer, but by looking at it, it kind of starts to make sense. Like, this is the table for comments in WordPress. We have like who's the comment author, what's their email, what IP they made this comment from, what are the names, what is the post that this comment is linked to? Was it like a child comment or like a parent comment, right? So gives a lot more context. Next thing that we can use is inputs, because that software again doesn't exist in a vacuum. It's taking some inputs, right? What are those inputs? What kind of inputs are we talking about here? There are four main types of inputs in any program. It's either user input, there's typing or clicking, or I don't know, doing something with peripherals or something, right? API endpoints, like the actual code base, the actual program, is talking to other programs and taking their output as its own input. API endpoints. Some files are configuration files. Some application watch like a file or directory for changes and read those changes, right? Environmental variables. That's also another input. So look for the inputs, and inputs can also give you insight and context into what this code base is supposed to do. Again, when you're trying to understand the code, it's not everything is in front of you. You have to look around. Okay, so you have a lot of those. You have a lot of context gathered, and you want to dive into the code, right? So we need to do a trace. We need to find a path and start tracing the code to see what that input or what happens to that input. Right? We want to go through a path and trace it. There are two main ways to do that. You either go depth first or you go breadth first, right? And there are two main ways, but I'm going to tell you when to use which one. Imagine this call tree, like function one calls function two from left to right, function two calls has like inside it is wrapping around function 5 and 6 and 12, all to the right? So, okay. If you want to go depth first, it looks like this. We go to the number 1 and number 2 and number 3. And then we go to number 4 and go all the way down to the 5 and go all the way down to 6, right? So this one, okay. Before I tell you the pros and cons, let's take a look at the other one. This is the other way. This is the breadth first, right? So you're just going at like a horizontal levels and different levels of the code. What you really want to do is a combination, right? If you here's a rule of thumb to choose which way to go. If you want to understand what exactly is in detail a single part of an application does, go deep, go vertical. If you want to understand, if you want to see the bigger picture, go broad, right? Okay, go horizontal. This is how it should be. Like this is how I do it personally. You can kind of change it to your likings, but this is how I do it. So I go like the first time. Imagine this is like a view a document function. I just go the first round vertically and understand that oh there's a login. If I'm not logging in that, I'm probably going to get redirected to a login page and then authenticated and then authorized to make sure that I can see the document and the document gets rendered after that, right? The second time, I'm like, well, how does that authentication works? Okay, so we are getting the form data, we're sanitizing it here. It's important. I'm not looking into the sanitization at this moment. I'm just accepting that there is a sanitization. I don't know if it's enough or not, right? Because I'm not going deep yet. Then there is a validation, and then. Okay, so that's how you basically navigate the code. Okay, we're gonna do it. Another thing that helps a lot is setting up a playground. What do I mean by playground? So you can use it in your IDE, whatever you're using. You can use like online repels. There are a lot of them. But what do I mean by an ID? By playground? Playground is a small space that you can quickly iterate over coding ideas, changing the input, changing the functions, changing the return values, changing everything, right? You can tear it down, you can delete it, you can break it, and you can quickly reinstantiate it, and it doesn't hurt anyone. So fast, contained, and the last one that I forgot. Okay, so I'm going to show you a few demos of what I mean by having a playground and basically um, quickly iterating over it. So, okay, this is a Python 3, right? This is a REPL, right? Read, evaluate, print, loop, REPL, right? Now, imagine you have some kind of can you folks see it or is it too small? Let me just I think it's better, isn't it? Okay, sorry. Do you want me to zoom more? Okay. Okay. So imagine you have code like this, right? That says import OS, and there is a path, and then you have a path, a join. Um, and this code is supposed to create a path for file uploads, right? Or HTML uploads, and then here you sanitize, you do whatever, and here is your file name, right? Like 1.jpg because I'm not creative at the moment. Now, when we print p, the path is not okay. Sorry, it's OS. Okay, right? Let's just join those two paths together and gave us one, and we're going to use this and upload the file here, right? But if you start iterating over it and you start reading the documentation, that's very important. That's part of the getting the context. You wonder what happens if you pass something like this, right? imagine that you cannot do this. It's sanitized. You don't have any way to bypass it, right? What if I just do this? I would expect it to give me something like this. Yeah, ugly, but doesn't matter, right? But when you have a playground, you can test it. This is what happens. So you get arbitrary file upload. You can do a lot of things with that, right? Because you have a small playground that you can play with ideas. You read something in the documentation, you can quickly try it and see, oh, okay, so that works. That's a vulnerability. It doesn't matter how much you are sanitizing the file name, as long as I can have like absolute addresses. It's gonna override the other part. Small, fast to iterate, and easy to tear down. Okay. Let's go for another demo. Okay. Sorry, I lost all my windows. Okay, now we're okay, now also the log and so what do you expect this what do you expect the output to be? So you usually should expect that it would be like 1, 20, 100, and 200. But when you run it, there you go. There you have it. 1, 100, 20, and 200. Right? So it's like sort in JavaScript, for example, in this example, is not behaving how you want it to how you want it to behave. It's behaving in another way. And imagine if those were like roles or authorization or used for authorization, that there would have been unwanted consequences. But having a small playground allows you to quickly iterate over your ideas. Right? So having a playground helps a lot to understand what's happening. Okay, a debugger, my favorite. So, a debugger, I'm going to show you all of this. Just bear with me a little bit. One of the things that the debugger does, that the print statement does not, is that it gives you the execution context, right? What do I mean by that? So when an input is traveling through your code, right? Data is traveling through your code. There is a lot of things that happen before it hit a certain line, and there are a lot of things that's going to happen after that line. A debugger lets you, allows you, and helps you to see the whole path before, right now, and the future. We're going to see that, right? A print statement is just like a uh, like a flash of light in prison, and it goes right. It doesn't give you information about what has happened, what were the other variables, what kind of modifications happen, and by whom, and by which part of the code. The debugger lets you see that. It also helps you slow down time, because I don't know about you, but my brain is not as fast as the CPU. I need time to think, right? I need to look at the code and slowly understand it. I can't execute it as fast as the CPU. A debugger helps me slow down the time, and we're gonna see it. Yeah, again, print statement is not a debugger. Other sources of insight. Git. Most security practitioners hate it. I don't know why, probably because they had bad experience with Git conflicts, right? So Git is one of the best um, stores of metadata about a code base. All the tickets, all the CVEs, all the fixes. You can see it everywhere. I'm going to show you that. I'm gonna go through how to use Git. Unit tests. That's another thing that security people are kind of averse to it for whatever reason. Unit tests are great because they are atomic small tests that are testing small parts of the code, and you can just attach your debugger to it. It's all written for you. You can start. It can give you small playground inside the code. We're going to see that. And finally, comments. Some people don't like to add comments to their code, and they argue that the comment is a code smell. Personally, I like it as long as it's not, you're not over commenting, or your comment is not just, as long as your comment is useful. Like sometimes you see a comment like "and if," like you don't say. I know it's an "and if," it's like a end of an if statement. So that could not those comments, good comments. We'll see about that. Okay, demo time. Let's take a look. So the software that I'm using here, I'm using JetBrains IDEs, right? Because I'm using it because I like them. That's the first reason. The second reason is that I've been using them for years now, and it's not worth it for me to just migrate all my workflow to another thing. But everything that I'm doing here, everything, right? You can do it with VS Code. You can do it with any other like IDE or text editor. You can do it with Vim. You can do it with NeoVim. You can do it with Emacs. You can do it with like Tmux and like a bunch of terminal windows. Don't worry about it, right? All you need to see here is the actual concepts, and then go and spend some time and build your workflow to support your needs. This is my workflow. You want to copy it, be my guest, but you don't have to. Okay, so first one is the beloved WordPress, right? So I have a WordPress instance installed here. Okay, right? And imagine that I'm a security researcher and I want to start researching. So I want to see how the login functionality works, right? All I need to do, I need to come and set up my project, and I'm keeping it vague because setting up your project is not something that I can teach you right now. It takes time. It's sometimes, more often than not, it's a fragile process, to be honest, and it's not fun. But once you do it, you don't need to touch it for a very long time. So this, just to give you an like a time estimate, this setup here for this presentation took me close to 45 minutes to set it up for all my for all the projects that I want to show you. But that's me, and I spend most of my days setting up different environment like development environments for different projects. First time you do it, it might take more time. So don't get discouraged. It is supposed to be not fun. Okay, so all I'm doing here as a security researcher, I want to start getting into the code base, right? I'm just keeping it simple. I want to see how the login functionality works, right? Set up my project, set up my debuggers. My debugger is turned on here. I'm listening to the debugger here. I'm going to go to wp-login.php. This is the file that handles logins, and I'm going to put a breakpoint here, or maybe here even, right? All I need to do now is just to reload this page and see what happens. So did you see that when I reloaded the page, that request came in and this window came into focus? I didn't click it, it just popped out, right? Popped out. So this is what a debugger does that you cannot do with a print statement. Right now, just give me 1 second. Right now, the execution is paused, right? And I can slowly as my brain needs me to, walk through the code. Right now we are on this line and it's not executed yet. I can jump over it, next line, next line, next line, and go over all of that. And look at it here. This is what I meant by the execution context. All the variables that are being set. Let me do this again. We are listening. I'm going to reload it. Okay. Look at here. Before we execute this line, these are all the variables that are in memory, right? Right now, we only have these in this thread. The moment we include that file, there we go. A lot more things got defined, right? And I can go into every single one of these and try to understand them. I'm seeing every single change that's happening. Right now, we have an if statement here. It's not being executed yet. It's checking if force SSL admin and not SSL, right? So that's the debugger. We can walk through it, walk through the code. I can see the action has the value of login. This is what my browser sent. The world is paused around me. I can see what happened before. I can see what's going to happen later, and I can see what's the exact state of the world right now. Right? Debuggers are superpowers. Use it. Okay. I'm moving forward. I'm moving forward. I'm moving forward slowly, and I'm understanding stuff. Oh, here's the set cookie. So this cookie was set here, and the secure value that was passed to it was false. Right? So it's not a secure cookie. Okay. Um, secure only is probably not set, because here, if I wanted to change it as like hard coded, I could change it here. So, and we can do this. We can just go through. Here's the switch statement, and here's where the actual login happens. Slowly going through the code, understanding each segment. Customized login, it's false. It's not customized. So we move forward. So um, that's the debugger. I hope this was like this demo and this slowing down the world was fun enough for you to give it a try. Another thing that I mentioned that your IDE should have is go to definition. Right now, I have this force SSL admin here. But what does it do? What's the code inside it? All I need to do is go to go to implementation. And here I can see the exact code. What is it looking at? So this is how it works, right? This is exactly how this function works. This is the function's definition. I want to see where. Imagine that I found a vulnerability here. I was like, oh, this is interesting. So where this functionality, where this function is being used, I can get a list of all the places this function is being called. Just like that. I'm like, interesting. What about the REST API? Maybe I can do something here, right? So you get what I mean. So, okay, so we went through the debugger, we went through go to implementation, find usage. What else was there? Another thing that I said is optional but super fun to have is actually having bookmarks. You see here, I put a bookmark here. So if I find something interesting, but I don't want to go deep right now, because if you always want to go deep, like as a rule, I always go deep, you're gonna end up in rabbit holes without having enough time to go through through the more important things. So this thing actually helps me a lot. So I can put a like a um, bookmark whenever I find something interesting, and then I can get a list of these bookmarks here, right? Oh, what about this? What about that, right? It keeps me from falling into rabbit holes, and also I don't forget about the interesting thing that I found that I want to check later. So that's what a debugger does. This is what a good IDE setup looks like. You don't need to use this exact software. You can use whatever you want. But that's the gist of it. And this doesn't only apply to like web platforms. You can actually do it for. I actually broke my. I wanted to show you an Android example. Like this is a Proton Mail Android app that I set up, and I had a debugger set here, but I broke it because I don't have enough free space to start this up. Let's give it another try. If it runs, no, I don't have enough free space. But again, the same thing. This just like boots up an emulated Android, runs the application. If you go to the search, you're gonna hit this breakpoint, and you can walk through it, right? So imagine how awesome is that. You also get a lot of logs from Logcat here. So unfortunately, I don't have enough space. Maybe at the end of the presentation, I'll just delete everything because this is a VM, and make enough space to show you that, right? It doesn't even need to be, as another example, I am going to actually show you Kubernetes. Same concept, same tooling, same mindset applies to the whole thing. So right now I have Kubernetes, and what did I want to do with? Okay, yeah, I remember. I told you that one of the good things, one of the greatest places to find information is Git. right? How it gets here, git menu here. You can do this with git command, git log, right? That's the command. But I'm just doing it here. It's nicer. I'm going to go and look at the git log. You see all the branches they're working on, all the commits that they made, and well, this is not even all the commits. That's my sample. Like everything, who made it, what kind of change they made. I'm gonna search for CVE, right? Let's take a look at the CVE, and you can see that there are a lot of fixes for the CVEs that were found in Kubernetes, right? So, for example, this one, a lot of modification to the Go mod. This is too big. Let me see if I can find something because I don't have a lot of. Yeah, that's okay. But let me just use this one. We can exactly see what has changed in that fix. So in that change, this file was completely added out of nowhere. This is a new file. This green thing is the change that were added in this file. What happened in this file? This is not a good example because I wanted to actually show you the before and after. Let me see. There was one about, if I'm not mistaken, was it about course? I don't know. Yes, this is better. Okay. So I'm gonna minimize this one. So in this, I used Git. I searched for a CVE and I found this one, right? And this is the exact change, the exact fix that was done in the code. So right now, as a vulnerability researcher, I can do multiple things. I can first understand how did it happen, right? I can understand. I can take a look at that and try to break the fix. What happened with log4j multiple times, right? Or I can try to come up with a one day if it's not being patched, if everyone hasn't patched it yet. I can look at the fix and understand what the vulnerability was and how this fix is preventing it. So how can I exploit it and create a POC for it, right? So a lot of context just in Git. Also, as a side note, there are a lot of good information inside the comments. Sometimes here you actually see a lot of good information. Not in this one, but worth a read. Okay, so that was Git. Another one, actually, let me see, course test. The test files, the unit tests, they are great. So this one actually, this is the same exact file that we looked at, and they say they fixed the course issue. This specific CVE. You can see the comments here. That's an example of a good comment here. Informative. Why is here? Why is it? What's being done here and everything. I can do this. Put a breakpoint. No, sorry. Let's put a breakpoint here, and then maybe even no. But run the test in debug mode. So instead of running the whole Kubernetes and downgrade it so I can see the vulnerability, I can just run that specific test for that specific part. Right here, I have again. I do have a debugger, and I can walk through the code and see, like for example, right here, the origin example, and see what is exactly happening with this fix, step by step, on trying to understand how this fix applies, how to break it, and everything else that I need for my task. Okay, perfect. So we went through that, and I really wanted to show you the Android one. Let me see. I just wanted to make sure that. Let me just uninstall this bunch. Um, just wanted to show you that it doesn't matter what the tech stack is. It works everywhere as long as you have a debugger. As long as you have the right tooling, you can understand the code. Let's see. Fingers crossed. Seems like it's working. Starting AVD. Let me run the graded build. This may take maybe a minute or less than that. For those of you who work with Android, you know that the builds are not that quick. But again, this is even if it doesn't work, this is exactly the same thing, right? I put a breakpoint on create event for the search functionality. So whenever you create the search, just hits the breakpoint and can go through everything. This is going to take a while, so I'm going to turn it off and leave it to your imagination. Okay, perfect. So that was demo time. There is one more way to understand code and understand context, and that's by asking for help. That's something I'm seeing a lot of people don't do, right? The only people who don't ask for questions are noobs and rookies. Asking for help, asking for help is not a sign of weakness. Actually a sign of strength. So whenever you get stuck, don't stay stuck. Work on it, understand it, and when you hit your limit, ask away. Ask questions from other senior people on the team or adjacent teams, or find someone, right? So don't be afraid to ask questions. And with that, uh, I'm calling it a day. And this is now question time. If you have any questions for me, I would be happy to answer. Oh yeah, okay. No, I'm seeing it right now. So, do we have any active questions? Oh yeah, 100%. Would you say there is a fine line between asking for help and independently figuring things out? Yes. So when I say asking for help, there are two criteria for that. First, you have to give it your 100%, maybe even 120%, right? But there are sometimes some limits. There are sometimes some again, historical context that you don't know, right? It's not because don't have the knowledge, it's because you don't have the tribal knowledge in that organization for that piece of software, right? And never ask for a solution, just ask for guidance. How would you approach it, right? There were times that I was working on code that or wrote code that broke everything, and a more senior member, an architect or someone, came and fixed it for me, right? But I always made sure to send them a message in Slack and ask them, hey, how did you do it? Thank you for helping me. Thank you for doing that. Thank you for avoiding an incident, or downtime. But how did you do it? How did you figure it out? Right? That helped me a lot. And they're usually more than happy, like always, more than happy to answer those kind of questions. Thank you. Great question, by the way. So indirectly asking is a skill to develop. Yeah, sure, 100%. I wouldn't say indirectly. I would say directly ask him, like, hey, I have a problem. Help me understand how to fix it. Right. Personally, I'm a very direct person, so that's my way of doing things. Um, but yeah, I'm going to change my camera to myself, so I'm not sharing anymore. Okay, I think that was the last question. I'm not sure what happened to my camera, but I don't know if you have my picture or not. But I think that was the last question. Thank you, everyone. And yeah, I'm on Slack. If you have questions that I can answer later, please ping me. Have a great day.